All right, so looking at 3 principles of experimental design. When we design an experiment, we want to make sure that we are controlling for any outside variables that might impact the one variable that we are looking at. We also want to randomize how things are put into groups. That way we can actually use our experiment, and our experiment is valid, and we can use it to actually draw conclusions on our study. And finally, our experiment needs to be able to be replicated. If you can't replicate your experiment, then something probably went wrong in your experimental design or in your conclusion, where you would need to look at that again. When you do an experiment, if your results are larger, if the differences are larger than what we get from randomization alone, then we say the results that you found are statistically significant. So looking at an example, if you want to see, again, we're looking at the dog food and whether or not the new dog food brand is healthy. To control for our control, randomization, and replication, we could do the following. So if you're trying to control the variables, so we are just specifically looking at dog food, you're going to want to look at a couple things. You're going to want to make sure that all the dogs are eating the same amount of food. So you're going to want to control portion sizes. That way the dogs are all getting the same amount of food. You're also going to want to control other aspects of their lives, like their owners, how the owners interact with them, the amount of love and attention and affection they're getting, also the amount of water, exercise, play, and sleep time they are getting. That way you are controlling for a lot of other variables that you can think of that might impact whether, like, a dog's personality or their health in any way. For randomization, you don't want to look at any pre-existing conditions, any traits, anything like that. You just want to randomly assign dogs into a treatment group and a control group. And then finally, for replication, you'd want to do this on multiple dogs, right? And even potentially multiple breeds. That way you can make sure that your experiment can be replicated, that your conclusion that was drawn is valid, and that you are consistently getting mathematical results that back up your conclusion. Okay, sometimes people draw out their diagrams of their experiments. That way you can more easily see what's happening. So this little green thing is a good example of if you are trying to figure out, the dog foods. You have 2 treatments. One group, they're getting the dog food. The other group, they are just a control group. They're getting dog food that we already know is good. We're going to give them that food over some time, and then we need to actually compare the data to make sure that what we are getting, or to draw a conclusion, and then we want to make sure that our conclusion is replicatable. That way what we are getting is valid. Alrighty, moving on to experiments and samples. So both experiments and sample surveys use randomization to get unbiased data. Sample surveys, you're randomly selecting participants from the population to estimate population parameters. But in experiments, we're trying to assess the effects of treatments that are usually done with a pool of volunteers. But we randomly assign the treatments to our volunteers to reduce bias. We have to do experiments on volunteers. You cannot force people to be a part of your experiment. That's probably pretty self-explanatory why, but, not everybody wants to try a new food or all sorts of things. So people have to volunteer for your experiment. Experiments cannot be forced on people. But yeah, they both help us get unbiased data. Okay, so to control treatments, often we compare a situation involving a specific treatment to the status quo situation. So think of it as like business as usual is your control treatment, and then your experimental units for who the control treatment is applied to is just called your control group. So that's pretty straightforward. When you are doing an experiment, super, super, super important, it needs to be a blind experiment. And what that means is people on both ends of the experiment, you don't really want them to know who's getting treatment, who's not getting treatment, and that kind of stuff, because people's individual biases may impact how they are interpreting certain characteristics, and it may impact their conclusion to their experiment. So when giving an experiment or conducting an experiment, there are two types of blind experiment. So there are two classes of individuals: those who are influencing the results, like the people that are being treated, right? The subjects, the treatment administrators, or the technicians, and then those that evaluate the results, the judges, the treating physicians, things of that nature. So when one of those classes is blind in an experiment, like say you are a part of an experimental group, but you don't know if you're getting a placebo, we'll talk about what that is in a little bit, or an actual medication, then you are blind in that experiment. And that's good, because if you know you're getting a fake pill, then you might interpret your characteristics and your body changes differently than you would if you knew you were getting a real medication. When both classes are blind, it's called a double-blind experiment. That is typically what you are striving to achieve, because that way nobody's individual biases can impact how they interpret their data. So an example of this, in an experiment about the pet food, we're feeding one group of dogs the new food and another group food we know to be safe. Our response variable is the health of the animals as assessed by a veterinarian. Should the vet be blinded? Why or why not? How would you do this? Okay, so should the vet be blinded? Definitely, because the vet might have some biases about that dog food, especially because that vet probably treated dogs that were severely ill because of that dog food before, when it was not safe. So that vet definitely needs to be blind. You could do this by just keeping the dog food in an unlabeled bag, label one of them A, one of them B. That way the vet wouldn't know what brand of dog food they're eating. Then extra credit. Can this experiment be double blind? Would that mean that the test animals wouldn't know what they're eating? That's exactly what that would mean. Double blind. I don't think the dogs know what they're eating, like brand wise, to begin with. So I would say that if you're blinding the vet, then this is probably a double blind experiment, because the dogs really probably don't know a difference between the brands. And then just to conclude, because I mentioned placebos. So placebos, you use a placebo, it's like a fake treatment. That way people don't know whether or not they are actually receiving the treatment. So if you're trying to figure out if a vaccine works or if a medication works, obviously people are going to know if they're in the control group. If you're just like, just go and live your life, nothing's different for you, we just want to see how your life folds over the next couple days. So we give people placebos. We might give them a fake vaccine or a fake medication. That way they don't know if they're getting the treatment or not, because if they know whether or not they're getting the treatment, then they're not blind subjects, and then their biases may impact our data. The placebo effect, what that means is people believe that they got results from this fake treatment. So maybe somebody doesn't know that they took a fake medication, and they're like, oh my gosh, I'm so much healthier now, I have so much more energy. And you're like, okay, but you took a fake medication. So literally nothing changed except your mindset. But that is what the placebo effect is, when your mindset makes you believe that, something in your life drastically changed, but in reality, you had a fake medication. Placebo controls are so effective that you should use them as an essential tool for blinding whenever possible. It's super obvious if people are getting treatment or not in most cases, so using a placebo when you can is a great way to control for biases. So I'm going to stop our second video here, and we will continue in our next video.